In today's video, I'm going to be showing you the benefits of using an animation controller. So the first thing I'm going to do is inside of Workspace, I'm going to create a model, and then I'm going to rename the model to Animation Door. Then inside of this model, I'm going to create a new part. And this part I'm going to name Frame. And I'm going to set it to a brown color, like so. And then I'm going to set the size to 181, and I'm going to anchor this frame, and I'm going to move it back and up to something like this. And I'm now going to create another part, and I'm going to name this part Slab, and I'm going to change the color, and then I'm going to set the size to 0.5, and I'm going to position this like so. The next thing I'm going to do is inside of the slab, I'm going to add a motor 6D, and then I'm going to set part 0 to the frame and part 1 to the slab. And if I now create a animation controller inside of the model, and if I go to Avatar, Animation Editor, and if I click on this model, we can see it asks me for an animation name. I'm just going to call it Untitled. And if we now look inside of server storage, we can see that there is now an animation door. And if I save this animation, we can see that the untitled animation got saved. If I now select the red part of the door and select the rotate tool, and rotate this part of the door, we can see it creates a keyframe. And if I press save, we can see that this keyframe gets added into Untitled. And if I select this and right click and press delete selected and press save once again, we can see that the keyframe gets removed. But you may have noticed that the door rotates around the center of the frame, which is not what we want. We want it to rotate around the frame. So what I'm going to do is close the animator. I'm going to select the slab, and then I'm going to use the move tool to move it to the right, like so. And if we now select the Motor 6D, we should notice that the position of C1 has changed to -4, where before it was set to 0. And if I open the animation editor once again and use the rotate tool and start rotating, we can see that now it rotates around this center, but this part over here has been offset. But instead of rotating around the center of the frame, what if I wanted it to rotate around the edge of this frame? So what I can do is let's delete this keyframe and let's close the animation editor, and I'm going to select the slab and I'm going to move it so it's perfectly in the center of the frame, and then I'm going to select the frame and move the frame to the left like so. And if we now look at the Motor 6D, we should see that this C1, which is the slab part, has an offset of -3.5, and the frame has an offset of 0.5. So if we go back into the animation editor and select the red part, we should notice that now instead of rotating around the center of the frame, it rotates around the edge of the frame. Okay, so now that our Motor 6D has been set up correctly, let's now animate the door. So I want the slab to start at 0. So if we press this little button over here, we can see that rotation is set back to 000 on this keyframe over here. And then once we get to 0.47, I want to rotate this door to open. So I'm going to drag and rotate to this like this. And then what I'm going to do is I'm going to select 0.353 and I'm going to right click and press add keyframe. And this is going to make this part here where it doesn't move. And then I want it to close again over here. Now, an easy way to do this would be to select this keyframe at the front, press copy, and then go over here and press paste. And now we have this keyframe, which has a rotation of 0. And we can see it rotates to this rotation over here. And then it rotates back over here. And if I now press the space key, we can see that the door opens and closes. And if I wanted to, I can select this keyframe and I can say ease in style, elastic, and ease in direction out. And if I now play again, we can see it springs open and then goes out like this. And if I wanted to, I can select this one over here, ease in style, elastic, ease in direction out. And then if we play again, you can now see the door opens like so. Now, try not to worry about the speed of the animation. We can adjust that when we play the animation track, but I want to change the style. So I'm going to right click on this one and I'm going to change the style to cubic V2. And I'm going to change the ease direction to in and out. I'm going to select this one over here, change this to cubic V2 and ease direction in and out. So if we now play it again, we can see it now animates like so. The next thing I want to do is when the animation reaches this midpoint over here, when the door is open, I want the animation to pause and not continue. So over here, I'm going to right click and I'm going to say add animation event. And I'm going to add an event and I'm going to call it pause. And I'm not going to pass any parameters into the event. And I'm going to press save. Okay, so we've now finished our animation. So let's save our animation. Now you'll notice that Roblox has created an automatic save here, but I want to save it into untitled. So I'm going to press these dots, save as, untitled. And it's going to ask me if I want to overwrite. I'm going to press yes. And now we can see all the keyframes that we've created. And we should also see the pause event over here. And the next thing I want to do is to publish this animation to Roblox. So I'm going to press these 3 dots over here. I'm going to say publish to Roblox. And then I'm going to say overwrite an existing asset. Now you can create a new one if you want to, but I have a temporary animation that I use over here. And I'm going to press save. And then it's going to give us the ID for this published animation. I'm going to press copy and then I'm going to close, and inside of the animation controller I'm going to create a animation and I'm going to paste that ID into animation ID and press enter. Now in the future, if you ever make some changes to this animation, you don't need to copy the ID anymore. All you have to do is press these 3 dots, publish to Roblox, overwrite an existing, and select the animation and save, and that will automatically update this animation over here. Okay, so I'm now going to close the animation editor. I'm also going to delete this automatic save and just keep the untitled one. Okay, so let's now create a script inside of our door, and I'm going to name this script animation door. And inside of this script, I'm going to create this script. So what we do here is we use the animator, which is this instance over here, and we're going to call the load animation, and we're going to pass in this animation instance into the animator, which is going to give us a animation track. We're then going to connect the animation track get marker reached signal, and we're going to use the pause marker. Remember, we created a pause marker within our animation. So once we reach this marker, it's going to call this function. And this function is going to just set the speed of the animation track to 0, which is to pause the animation. And then once we've connected to this event, we're going to start a while true do loop, and we're going to wait 10 seconds. We're going to play the animation. Now, while this animation plays, it's going to pause itself once it reaches the pause marker. And then after 10 seconds has ended, we're going to start the animation again by setting its speed back to 0.06. So we start it, it gets paused, and then we start it again. Okay, so if we now play the game, and if we wait 10 seconds, we should see the door opens, and then it gets paused, and then it starts playing again, which makes it close. And then once 10 seconds has ended again, it should open again. So now we can see the door keeps opening and closing and opening. Okay, let's now create another door, but this time let's use the Tween service to open and close it. So I'm going to duplicate animation door, and I'm going to rename this to Tween door, and I'm going to delete this, I'm going to delete this, and I'm also going to delete the motor 6D, and I'm also going to rename this script to Tween door. Okay, so the Tween door and animation door are not overlapping. I'm going to move these two doors. And now inside of this slab, just like the motor 6D, I'm going to create a world. And I'm going to set part 0 to the frame and part 1 to the slab. Now you can see that the slab moves to overlap the frame, and if we move the slab, it's going to destroy the world. So what I'm going to do is, just like we did for the motor 6D, I'm going to copy these positions into the world like this, and this position over here like so. And now we can see it has the same offset as our motor 6D. And now I'm going to go inside of the Tween door script, and I'm going to delete the animation script, and I'm going to paste in the Tween script. So this script works a lot like the animation script. So let's move this to the right. So what this does is we first get the Tween service, and then we create a Tween info, and we're going to use cubic and in and out, just like we did for our animation. And then I'm going to get the C frame for C0, which is this one over here, C0, which is this position over here. And then what I'm going to do is I'm going to multiply that C frame with a rotation C frame, rotating on the y-axis with an angle of negative 112 degrees. And I'm also going to create another C frame that just passes in the C frame with no rotation in order to close the door. And then, just like we did for the animation, I wait 10 seconds, play the open tween, wait 10 more seconds, and play the close tween. Now, if you're wondering how I got this number over here to know how much I need to rotate the door by, if we go into our animation, and if I select a keyframe and select this slab, we can see that the orientation was set to negative 112.5. So I just copied that number over here. Okay, so if we now play the game, we should see that the animation door is on the left and the Tween door is on the right. And after 10 seconds, they should both open. And after another 10 seconds, they should both close. Okay, so let's now create a door that uses physics instead of animations or tweens. So I'm going to duplicate the Tween door. I'm going to move it to the right, and I'm going to rename this to physics door. and I'm going to delete the world. And then I'm going to create two attachments. So I'm going to create an attachment inside of the slab and a attachment inside of the frame. Now for the attachment inside of the frame, I want to move it so it's over here, 0.5. And for this attachment over here, I want to move it over here, so it's negative 3.5. So the two attachments overlap one another. Another thing I want to do is I want to rotate these attachments because it won't rotate around the correct axes. So to do that, I'm just going to set this to 90, and the same for this attachment. Set this to 90. Okay, so now inside of the physics store model, I'm going to create a hinge constraint, and I'm going to set attachment 0 to the one inside of the frame, attachment 1 to the one inside of the slab, and I'm going to set actuator type to servo. And then for the responsiveness, I'm going to set this to 5. For the angle speed, I'm going to set this to 0.3. And for the torque, I'm going to set this to 10,000. And now I'm going to go inside of the physics store script. I'm going to delete the Tween code, and I'm going to replace it with this code. So all I'm going to do is wait 10 seconds, set the hinge constraints target to negative 112.5, then set it back to 0 after another 10 seconds. And if we now play the game, we should see that all three doors open and close, but the physics store is going to be ever so slightly different because we're not going to be using cubic. So cubic means that it starts slow, speeds up, and then slows down, where the physics store will just keep a constant speed to go round. Another thing you may notice is if I stand on the physics door, and when the door opens, it's going to make my character move with the door. But if I stand on the Tween door, we can see that my character does not move with the door, and the same is true for the animation door. If I stand on the animation door, my character won't move with the animation door. Okay, so let's now benchmark these three doors to see how they perform. So what I'm going to do is I'm going to move these three doors into server storage. And then inside of server script service, I'm going to create a new script. And inside of this script, which I'm going to name clone, I'm going to simply loop from negative 30 to 30, and then from negative 62 to 2, negative 2. And I'm going to clone the animation door from server storage, and I'm going to pivot it using the X and Z coordinates, and I'm going to parent it to workspace. Okay, so if we now play test the game, we should see a whole load of doors. We can see that my CPU usage is around 5, but once the doors start animating, we can see the CPU usage goes up to around 16. And when the door closes and stops, it should go back down to around 5-ish. Here we can see the CPU dropped for a second, and then once it started moving, it went back up to around 16. Now, if we look at the received network data, we should see that when the animation first starts moving, there's a small spike, but while the animation is playing, there is no network data being used. And the reason for this is that the animation is not replicated from the server to the client. Only the state of the animation is replicated. So when we start playing, the server will tell the clients to start playing the animation, and then the client will independently, without any information from the server, move this part to open or close. So that's why we can see a small spike when the server initially starts the animation, but while the animation is playing, there should be no data usage. So that we remember these stats, I've written down into Notepad. So animation doors, use around 16 milliseconds of CPU while the door is moving, and it will use 0 kilobytes while the door is moving, but will spike up to 100 kilobytes when the door starts moving. Okay, so let's now test the tween doors. So I'm going to change this animation door to tween door and press play again. Now let's keep our eye out on the CPU. So while the door is not moving, it's around 5. And then once the doors start moving, we can see that CPU goes up to around 60. And then goes back down to 5. And then once they start closing again, goes back up to 60. And if we now keep our eye on the received amount of data, we can see it goes up to around 1,800. And when the doors stop moving, it should go down to 0. And then it'll go back up to around 1,800. So here we can see that the tween door uses not only more CPU than the animation door, but also sends a huge amount of data because it has to constantly share the property that gets updated when it's tweening the door. Okay, so let's now test the physics door. And the first thing we'll notice is that the physics doors don't really open and close that well. So if we keep our eye out on the door, we can see they start opening, but they're very laggy, especially the ones far behind. And they don't fully open. And now they start closing before they fully opened. But if we ignore the fact that they're not fully opening and closing and just look at the CPU usage, we can see they use around 32 milliseconds of CPU and they use around 41 kilobytes on data. Now, if I go back to the physics door and select the hinge constraint and change the angular speed from 0.3 to 3.3 and press play, we should see that the doors now fully open and close. Another thing we'll notice is that the doors that are close to us will animate quicker and the ones behind will be delayed. And we should see that the received network data stays at around 41 and our CPU stays at around 30. So what's happening here is, unlike the tween, which uses 1,800 kilobytes a second, Roblox is most likely throttling physics to prevent it from going too high, so it's acting strangely. So hopefully this video has shown us that the animation controller is very efficient on CPU usage and is also very efficient on network usage, because when the animation controller is moving the parts, it doesn't actually replicate the animation, it only replicates the state, which causes a small spike when we first start the animation, but then uses no data while the animation is playing. But if we compare physics to tweening, we can see that physics uses less CPU compared to tweening, and we can also see it uses a lot less network data compared to tweening. But the problem with physics is if you push it too hard, it's going to start throttling and acting strangely. But if you don't push it too hard, it should work correctly. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.